So completable futures obviously has some benefits, but as with almost any technology, it's not all unicorns and rainbows. There are some downsides to using completable futures, so let's talk about those a little bit. And again, the comparison point here is not just some abstract parallelism framework, it's parallel streams, which is the main obvious one to compare and contrast with. So one of the key things to note is it's typically easier, often a lot easier, to program parallel streams than completable futures. So why is that? Then here's an example of kind of comparing things side by side. In general, asynchrony patterns aren't as well understood. A lot of people have a harder time thinking about things asynchronously. In contrast with parallel streams, you can just kind of write things in a synchronous way. Another cool thing about parallel streams is it's really quite simple to program it first with sequential streams, get it working, and then just flip the switch and automatically you're running in parallel. So that's pretty cool. You can't do the same kind of thing with completable futures. Once you go down the completable futures path, you're in a different paradigm of programming. If you take a look at more under the hood of the implementations of these behaviors, sort of at a high level, the two approaches look very similar. But if you really take a look carefully at what the behaviors are doing, the behaviors for the sequential versions are a lot simpler, and the ones for the asynchronous version take a lot more thought. Those took a lot longer to run, to write, a lot longer to explain, and so on. So there darn well better be a reason to go to all this effort, and the real reason is performance. And there's always a trade-off between everything, so the trade-off here is between performance of the computing system and productivity of the humans. So it's sort of performance of people versus performance of computing. So completable futures are more efficient and scalable, but they're a little harder to program, as we talked about before, because asynchrony is just a little bit harder to get your head around. In contrast, parallel streams are easier to program because you can start with a sequential stream where there is no parallelism. You can get things working, and then you can go ahead and speed it up just by saying, parallel stream instead of stream. But typically not going to run as fast. As usual, you need to know the patterns of effective programming. So the better you understand these different approaches, the better you can go in and try things out. In my experience, honestly, most of the time you're going to have an easier time using streams and parallel streams. It's just a more intuitive paradigm to most people who have not been raised on a steady diet of asynchrony. So you might think about that and start off with that. And if for some reason that doesn't quite get you with what you want, then you might consider converting your streams-based approach to a completable futures-based approach. But the cool thing is you can combine the two. You can have sequential streams providing the structure, and then completable futures providing the parallelism. Okay, so those are some of the downsides. Again, once you master the paradigm, it's not too bad. It's also can be a lot more mysterious to read people's code when it's written with completable futures, because people do all kinds of crazy idioms that may take a while to get your head around.